Hey everybody, it's Mr. Carr again. Today we're going to be talking about in our congruent triangles. We're actually going to take a break from geometry stuff and we're going to talk about algebra again. Because the main reason that we are doing that is when we look at our goal ultimately is to talk about triangle congruence. And you look at target 3 here, prove triangles congruent. That prove idea is what we're going to be practicing today, but with some stuff that you've probably done in the past. Okay. So when we proving means that we are trying to make some logical statements that all follow along one to the next to the next to the next. Okay. So that's what we're doing when we prove. So that's our goal here. So when you look at this one, algebraically, we start with this statement here. This is what's given is that 3 times parentheses x plus 5 equals 21. In the end, we want to show that this is true and why it's true. So there's going to be a variety of things that happen here. So let's start with some of so basically what happens is we're just going to explain every single step it takes to get from here to the next box. So for example, how do I get from that first box to the second box there? Well, the only thing that would have happened was 3 would be distributed to the x and the 5. That's how we get 3x plus 15. So that my reason for doing that would be the distributive property. From there, to get from this box to this box, you notice how the 15 is gone and we changed the 21 on both sides. So the idea would be that I would have to subtract 15 over. This is what's called the subtraction property. Oops. I'm running out of space here. Subtraction property of equality. Okay. I'll use some shorthand in a little bit there, but I don't like how messily I'm writing this. Equality. There we go. Subtraction property of equality. What that basically says is if I subtract the same number from both sides of my equation, I'm not changing the value of the equation. I'm just making it look a little different. So I'm going to maintain my normal equality as long as I subtract it from both sides. Okay. From here, to get from 3x equals 6 down to x equals 2, my final step in my algebra is to divide. Well, there's a name for that too. That's the division. I'm going to call property of equality just POE. Okay. So the division property of equality. So that's what we're trying to show with a proof. When we do proofs, we're just showing that like every step we take has a reason we can do it. So that's all that we're trying to do. We're trying to show this logical, this leads to this, this leads to this, this leads to this. Okay. We'll talk more about how to do proofs in a variety of different ways, but just for now, this is just a very basic version of this to make sure you understand like what's going on. Okay. So we start with our proof here. In my first statement box, I'm going to just rewrite the given. Okay. All right. So this is given. So then I'm going to go through and look at, well, what would I normally do for solving an algebra problem? First thing I would do is I would combine my like terms. I would take 5x and 2x, put them together as 7x. Okay. And that's literally what I'm going to write. I combine like terms. Okay. From there, technically speaking, I would do 2 steps here, but I would do subtraction. Like if I would want to bring the 3x over here. So I'll do that. I'm going to do it as 1 step just so I could save a little bit of space. I'm also going to do addition here. I'm going to do both at the same time. So I'm actually doing addition and subtraction property of equality here. Okay. I'm adding and subtracting the same thing to both sides. So I added the 18, so they'll cancel out. I subtract the 3x's, so those cancel out. I end up with 4x equal to 2 plus 18 is 20. And then my final step to get to x equals 5, divide both sides by 4. So that x equals 5. And that was, again, the division property of equality. In terms of algebraic proofs like this, we can talk about a variety of things. We can talk about, what you see here, addition addition property of equality, subtraction property of equality, division property of equality. There's a multiplication property of equality. All those property of equalities just refer to when I take something, I multiply it to both sides, okay? Or I add to both sides. I'm doing the same thing to both sides of an equation. That's the property of equality. Some other properties you might use would be something like this. And this is going to come back to our geometry stuff too. Reflexive property, symmetric property, transitive property, and substitution property. Okay. So these are true for any kind of math concepts, but especially for geometry, we'll use these more. Reflexive property is when a quantity is congruent or equal to itself, A equals A. Here's how we would typically use this. If I give you, let's say, a triangle, okay, and I go like this, A, B, C, D. So technically, I've got two triangles, 1, 2. If I look at those as two separate triangles, they share a side here with the AD. So my reflexive property here would look like this. It would look like AD is congruent to AD. That's what reflexive means. It's congruent to itself. Okay. Symmetric property, if A equals B, then B equals A. That's just the order. We can swap those around. And if I do it with numbers, I could say X equals 5, 5 equals X. They mean the same thing as the goal there. Transitive property, if A equals B and B equals C, then A equals C. This is a good one because what we're doing is we're kind of eliminating that middle step. Okay. So you're making this kind of also called like a chain logic. You can, this leads to this, this leads to this, this leads to this. Therefore, the first thing leads to the last thing. That's what we're saying. So we can cut out any middle steps there to go right from the first thing, draw the conclusion that it's equal to the last thing. Okay. And then substitution. And that's whenever I take this substitution property, if I give X equals 5 and X plus Y equals Z, then I can replace that X with the 5. That's what we're saying with substitution property. And that's things you've done. You're just, you're substituting a variable for a number. So we look at these down here. These are just 3 examples. If A equals B and B is less than C, and then that means A is also less than C. What we're doing is we're doing substitution property here. Whoops. Substitution. Okay. We're basically taking the A and swapping it out for the B. AB equals XY, XY equals AB. This is symmetric property. Okay. All we're doing is just switching the order on those things. 1 is congruent to 2, 2 is congruent to 3, 1 is congruent to 3. This is transitive. And lots of times people might use substitution and transitive like kind of interchangeably. The biggest thing to me was with transitive property, it's the fact that the relationship remains the same throughout. Like in this case, they're all equal. Here, everything's congruent. So 1 is congruent to 2, 2 is congruent to 3. Therefore, 1 could just jump right to 3. That's transitive property. Whereas this one, A equals B, is a different relationship from things being less than each other. That we're actually substituting is the idea. Okay. So just make sure, I think in terms of like what you're describing here, I usually allow substitution pretty much all the time. It's fine because technically you could still use substitution, but make sure if it's transitive, like if you're going to use that phrase transitive, that's what it actually is. All right. That's it from our introduction to proofs. We'll go more in depth into these ideas as we go into the more of this unit, but that's it. All right. Take care, everybody.